Can you hear me? Lakshita, can you hear me? Hello. Can you hear me? Hello, hello, hello. Lakshita, can you hear me? Okay.
Oh, I can hear you now.
Okay. So what happened to you yesterday? You
My
were in
Wi-Fi
here.
stopped working. There was a thunderstorm.
There was a thunderstorm. Okay. So you're back. Okay. So last class we are working with the polynomials, and then there's a good amount of questions for the homework. So I'm not sure that you have done the homework on this worksheets. So this is what we are talking about. Unit 2. There's a lot of questions with factoring, different type of factoring, and then also there's some application questions here. So how far you have done on that?
I started the factoring, but I didn't do the unit 2.
So you started to do the factoring, Olivia, but you didn't have a chance to do these questions.
Yeah.
All right. So do you have an access to this OneNote on the other side?
Yeah.
All right. So there are certain questions that I need to discuss before I going back to the functions. So you can actually use the Jamboard from yesterday. So you don't need to do a new Jamboard. So I would like to going back to some specific questions. So let's start out with some easy one. Can you do number 2 on the Jamboard from yesterday's Jamboard? The word problem. So I would like to see how it
Okay.
was. Use the Jamboard from last class. Are you working on that? Did you access the Jamboard from the classroom, Google Classroom from yesterday? Lakshita, can you hear me? Hello? Hello? Lakshita, hello? You don't need to draw the diagram. So question is asking, find a fully simplified expression for the ratio of the perimeter to area. So show just to show the steps. You're on the right track. I'm not sure why you're raising it. That's correct expression to start out with. Perimeter is 2 times length plus width. Okay, keep going. You're on the right track. Keep going. That's a not 4C. I'm not sure where to get a C from. It's 4X. Right? That's 4X. And then you're missing a 6X. Okay, keep going. There's a 6X squared. I'm not sure what happened in there either. Okay. So you're going to collect the likely terms, simplify that expression. So I won't really simplify like that, because if you see, the final question is asked to find a ratio, isn't it? So we really want to keep them in a factored form. So 2 times 15x squared, 15x squared minus 4x is already in factored form. So don't simplify by opening the bracket. Now write an expression for the area and then find the ratio. So write the expression for the area next. Okay, that's correct. So now try to find the ratio. So you don't need to simplify that. You're going to keep that in factored form. You need to find the ratio of perimeter to the area, right? So your perimeter P divided by A. Your perimeter divided by area P divided by A. And then they ask to simplify that. Let's see how it's going on. So you got there. So how would you simplify? So you got so far so good. So you see my screen, right? So perimeter is equal to 2 times 9x squared minus 4 plus 6x squared minus 4x. And then area is going to be 9x squared minus 4 times 6x squared minus 4x. And then that's being simplified 2 times 15x squared minus 4x minus 4. And then this one, you just keep it like this, and then you don't know what to do. Is that correct?
Yeah.
All right, so you need to factor it. So at this point, we need to work in factoring. So we're going to looking at the top part. So we're going to see that if you can factor the top part. So that's a factoring trinomial. 15 times 4 is 60. We need to break the 60 into 4. So 10 times 6 will do the job, right? So remember the cross method we are talking about, how to break it. So 15 can be factored, so several ways. So we're going to go back to see it will make sense. Or the way to factor it, we take the product of that term A and B, product of the term A and C, and then see if we can get the middle term. Of course, I can get the middle term. So that's going to be 15x squared minus 10x plus 6x minus 4. Now, for these two, I can common factor 5x, x minus 2, and then plus 2, x minus 2. So that's going to be factored nicely 2 times into 5x plus 2 and x minus 2. Are you following that?
Yeah.
Okay. Now on the bottom part, there's a lot of factoring can happen. First thing is a difference of squared. So we talk about the difference of squared, 9x squared minus 4. So how do I factor 9x squared minus 4? This can be written as 3x something squared minus 2 squared, right? So a plus b, a minus b. Did I talk about that factoring last class?
Yeah.
Yes. So this is going to be 3x plus 2 times 3x minus 2. Now this one, first step to factoring, you need to take the greatest common factor out. So 2x come out. So that is going to be 3x minus 2, right? Now we're going to see, is there any chances we can cancel some of the factors out? So technically speaking, 6 squared, there's no common factor except that 2 and 2 will cancel. So we left over with 5x plus 2 into x minus 2 over 3x. You can see this is going to be 3x plus 2 times 3x minus 2 whole thing squared times it by x. Now the denominator cannot be 0. So x cannot be 0. This cannot be 0. 3x plus 2 cannot be 0. So x cannot be negative 2 over 3. And then a 3x minus 2 cannot be 0. So x cannot be 2 over 3. Are you following that restriction?
Yeah.
Okay. So this question is a little challenging. So open up the next Jamboard, and I want to see how would you get started with this. So go back to the second page of the Jamboard. You can raise the one that we have did last class. So you have to simplify it. So let's see how we just try it. So this question is very easy. You will get confused for a valid reason. So what the valid reason people will confuse in here, so I'm going to help you with the first part. So we're going to break down it, okay? So if you look at here, there's a plus and there's a division, isn't it? Do you see that? There's a
Yeah.
plus and so we have to deal with this guy first, order of operation for the bed mass, isn't it? So we need to simplify this part. So what I really want you to do is, rather than doing all of them, first step, this is term 1. Can you factor term 1? Show me how would you factor term 1. Then you're going to show me how you factor term 2. That's the first step. Just do that in separate. So I want to see how would you factor term 1, then term 2, then we will go from there. So only just do the factoring for the term 1 first. No, you don't need to write the whole thing. Just show me part one. Take this term and show me how would you factor it. I don't want to see that you're writing the whole thing because that's a really big expressions. Can you just factor that only? That's the only one I want to see it. Then we will see how to factor 2, and then we will go from there. You get stuck? Sorry?
Pardon?
How you get stuck on factoring the first part?
I only I didn't finish
Okay, why I'm not seeing the work? Are you writing page 1 or page 2?
page 2.
Okay. You're on the right track, just you got the idea, so that's going to be -4. Yeah, keep going. Did you learn factoring before? In grade
I
9?
learned it in no, I
Sorry?
learned it in Kumon.
Or
I
you
learned
learn?
it in Kumon.
Okay, are you still going to Kumar?
No.
Okay. Okay, Jason, so for a second. All right, so you got that part done. So now after that, can you do part 2 factoring? So that's perfectly came out nicely. Yeah, that's right. Yeah, that's correct. You're on the right track. All right, so now what you're gonna do, you got 1 and 2. So this is pretty straightforward. So I believe that you got an idea what to do on that part. And so what is the next step is as you have factored the first one, we will simplify this one first, right? The division. So when you simplify the division, then we're going to be simply add them together. So let's see how we can get this question done. Can you right now write? I will write on my screen. So you already have the factoring done. So I'm going to going back to write that in factored form. So it's easy for you to copy. Did you erase the previous one?
Yeah.
All right. So you have to have that to just simplify the word, because after that, so let's going back to this part. So you have done that part, don't erase that. So this is going to be 2x squared, and then this is -4. So you get minus x minus 4xy plus xy minus 2y squared. This is easy to factor. Again, this is going to be 2x squared minus 2xy plus xy minus y squared. And something that is going to be 2x into x minus y plus y into x minus 2y. So 2x into x minus 2y, and then plus y into x minus 2y, and then divided by, this just became the 2x out. So there's going to be x minus y plus y, x minus y. And then that's being factored 2x plus y into x minus 2y into 2x plus y into x minus y. Now the beauty here is we got 2x plus y. 2x plus y is a factor in both numerator and denominator, isn't it? But we're not going to simplify that. And then you already just did the other part. So what I'm going to do right now, I'm going to type the factor 2x squared times 4x plus 1. Because when you're dividing, you're multiplying by the reciprocal, isn't it? 4x plus 1 into x minus 2y, isn't it? Now let's look at it. Even though it's a complex one, these two gone, isn't it? 2x plus y, 2x plus y gone. X minus 2y, x minus 2y gone. So we only left over with 2x over x minus y. Did you see that? Restriction applied. We didn't specify the restriction yet. So the restrictions are going to be x cannot be minus 1 over 4. X cannot be 2y. X cannot be y, right? And then the other restriction is going to be x cannot be minus y over 2. Now, big expression came out nicely, simple one. Then what we're going to do, we're going to be simplify the next one, and then we're going to add it. So technically, this question is going to become 4x squared plus 4x minus 3 over 2x squared minus 3y plus 3x minus 2xy plus 2x squared over x minus y. So can you simplify? Let's see if you can get the final answer correct from there onward. So this is the next step. We need to simplify this part right now, factor it, and then find the least common multiple and simplify. So I do have an answer. We will cross check it to get the right answer. So you need to do again factoring the denominator and find the greatest common factor. you can write the denominator in a factored form, right? So you don't need to write that. You see that you already know. Okay, all good, keep going. Okay, look like you need more space. Say just take the side space to write it, if that's possible. Otherwise, you need to copy the whole thing back. I think there's a way to duplicate the slides. If you have a space, you can squeeze it right now because the other side will be factored. Okay, cool. I think that, you know what, duplicate it. Oh, go for it, Okay, if you can squeeze it, that's fine. If you can squeeze it, that's fine. So I want to see how would you get the least common multiple. I'll be back in a minute.
Is that right?
All right, so let's see how's that going.
Pardon?
No, I'm just trying to see how's it going. Okay, so you cancel that, that's correct. So you got 2x squared, x minus y, 2x squared plus 2x. Okay, so let's go back to see if you got the final answer right. Question number 5. Question number 5. Question number 5A. Oh, I'm just looking at it, 5A. X minus 5 is correct. Yes, that's right. So you're good with that factoring. So we're gonna moving back to our lesson. So this handout, it's from the day 1, so which is July 5th. So we started to talk about functions, isn't it? Remember, we started to talk about function and then came back to this unit. So we're gonna going back to the functions again. So just going back to, when it's come to a function, we talk about function notation. So we're gonna going back to a concept called domain and range. The domain and range is basically define functions. Domain is going to be defined at x values and the range is going to be defined at y value. So there are technically, we have to use some syntax to write it. So we will write domain is equal to, most commonly used syntax is going to be this sign and real. So what this basically saying that x is an element of real numbers. Real numbers is all the possible numbers in a number line. And then sometimes we also need to specify some restriction. So what we're going to do, I'm going to going back to some examples to show you how to find a domain and range. So the domain is going to be possible x value. So if you look at here, this graph doesn't continue. It's just only have specific dots. Because it has specific dots, the domain is going to be specific values we can list it. So x take, you can see -3. And then we can say x also take -1. X also takes 0. X also take 1. X is also take 3. The range, the possible y values. So the y values is taking it. So we're going to go from the lowest one is take -2. And then we can say it's actually taking the value of 1. Then we say actually taking the value of 3. Did you see that how I listed here? Because there are very discrete values. But here, there are so many possible values. If you look at here, the graph going from here to here. So if you're looking at all the possible x values, so all the x values from this onward. So we can really list all of them, comma separated. So in this case, we will say domain, x's belong to a real number, but there is a restriction. X is between, you can say start at -5, but x is stopping at 6. Do you see that? Are you following that picture? How do I write that expression? Okay, now we're going to go back to talking about a y value. So if you look at a y value, the y values are kind of squeezed. So if I do a little estimate here, the y values are squeezed between these two. So I'm going to say range is y belong to real. Right here, y is, let's imagine this -1.5. Y is between -1.5 inclusive, and then y is equal to 2. Now this one is a little tricky. So y is a little tricky. Let's going back here. So this graph going here, so just stopping at here, this graph stopping at here. So if I draw the boundary, I'm going to say x belong to real for the domain, but we can't say x is actually greater than or equal to 6, right? And then if you look at the graph, this dot basically saying x is not defined here, the graph, but this dot say there is a value for the function, then x is equal to -1. So x go from -6, the boundary here is 4. So we're going to say x is actually between -6 to 4, right? Now, once looking at the y value, if you can see, the largest y value you can get is 8, right? And the smallest y value you can get it -2. So I'm going to say y is greater than or equal to -2, less than or equal to 8. Are you following that? Hello?
Yeah.
Okay. Now, example 2. In example 2, this graph is given pretty obvious. We just read from the graph. When the if the graph is given a different way, an equation, how are we going to find it? Plus a. When the function is given at a pair of values, all we're going to do is we're going to looking at the x coordinates as the domain. So the domain of f of x, that's how we write, is -4, -3, 0, 1, 5. The range of f of x is going to be -1, 2, 2, 7, and 0. But we're not going to write a duplicate 2. We will only write one of the 2. We don't write it. So -1, 2, -1, at 2. Oops, what's happening here? 2. Well, I have a 0, so I'm going to list the 0 first, and then I'm going to list the 2. Now we have some dilemma here. So in grade 10, you supposed to be learned this graph, quadratic relation. And then this is a grade 11 function. So this is the grade 11 graph. This is the grade 10 graph. So only way we should be able to answer this question is, one second. Going back to see if I have a parent function to talk about it. Inverse graphically. Okay. So that's basically inverse exploring. Oh, yes. So what I'm going to do is actually going back to the exploring properties of some parent function first. Then we're going to going back to talking about how this works. So this will give an idea how it's going to look like. So first function, you have seen linear function. So you should not have any problem in understanding what a linear function is. So I'm going to draw a rough sketch of the linear function. So characteristic of a linear function. So the linear function is basically go from here to here. So if I'm going to draw it, so that's a simple sketch, isn't it? That's a linear relationship you have seen in grade 10 class and also grade 9 class.
Yeah.
Now, the domain and range for the linear function is pretty straightforward. So the domain is x belong to real. Domain is simply x belong to real. It's take all the possible x values. Similarly, the range is y belong to real, right? You see that? So are you following that? Hello?
No.
You're
I
not
don't get
following
it.
that. You didn't get it. Okay. So what that basically telling, and if you really look at the graph, y is equal to the linear function. If you're looking at all the possible x value it can take, it's simply every single values on the number line is a possible x values, isn't it? The linear function can take another way. Put this way, can you tell me an x value for this function where you cannot able to find a y value? Can you tell me a possible x value where we can really evaluate a y value?
Mm,
Tell me a possible x value such that we can really evaluate the y value. Can you think about an x value that where y cannot be calculated? No? Still thinking?
no.
Still thinking?
No. Yeah.
Sorry? Okay. So tell me an x value when I plug in, I can really find a y value using this formula because that is what the function is. Fx is equal to x. What's up? Still thinking to find an x value where you cannot find a y value?
Yeah.
So you have to keep on thinking because there's no such x value exists. You can plug in any values in a number line. So if you look at a number line, this is the number line. So we start 0, this is 1, this is 2, this side -1 and -2. In between that, you got 0.5, you got 0.51, and then there's so many lines in there. We call the whole numbers in the number line are real numbers. So the real numbers are every single numbers on the number line, except the number inside the square root with a negative sign. We're not going to talk about that. So in this case, if I extend this curve, this curve is going to be keep on going both direction for infinity, isn't it? It will go to infinity on here on the positive x-axis direction and also go to the negative infinity, isn't it? Are you seeing the curve?
Yeah.
So what
Yeah.
we say if that's the case, the x value the graph can take is simply all real numbers. It's take every single real number. Now, if you look at this way, if I'm going to be looking at the possible y values, your y value is also all the possible numbers. There's no restriction on the y. So we say the y value, which is described as domain, it's belong to all real numbers. Are you following that picture at this point?
Yeah.
So now comes the problem. Y is equal to x squared. So you are going to grade 10. So I don't think so that you have learned what is y is equal to x squared. But what we're going to do is we're going to graph this. So let's observe some points to graph this. So I'm going to have x here, y here. So I'm going to put some point, -3, -2, -1, 0, 1, and 2. So let me calculate that point using that equation. So y is equal to x squared. -3 squared is -2 squared is 4, 1, 0, 1, 4. Do you agree with those values?
Yeah.
Okay, so now let me go back and plug these points in the graph to see what would I get. So I'm going to go back to plug in these points in the graph. -3, 9. So -3, 9. -2, 4. Minus comma 1, 0, 0, 1, 1, 2, 4, 3, 9. Did you see that how I plot those points? You see
Yeah.
how I plot those? Okay, my question is, do you think I can connect all those points with one line?
No.
No. So there's no way I can connect these points with a line. So we can only connect these points with a curve. We can only connect these points with a curve. This curve has a specific name. We call this curve as parabola. Parabola. The graph that defines a parabola is known as quadratic relation. We already talked about this quadratic relations indirectly because we know how to factor this expression, isn't it? Don't we spend time on learning about how to factoring a trinomials?
Yeah.
So we're going to be talking about in grade 10 class what a quadratic relation is. But right now, the quadratic relations produce a shape of a curve like this. Now we're going to observe the domain and range. If you look at the curve, if I'm going to keep on, so let's go back this way. So let's go this way. If I'm going to be simply choosing a x value somewhere, right? So randomly choose the x value. Eventually, I can able to find a y value. There's no question on that because this graph is going to be spanning on so and so and so. I can still find a y value for any x value I choose. You see that how the graph will go forever? It will go forever like that. So if you choose an x point, you can still find out this point will cross my graph, isn't it? Are you seeing that?
Yeah.
So therefore, the domain for the x value, the domain for this function, the domain is x belong to real. Now let's look at the y value. You see that this graph is not going below the x-axis, isn't it? Do we have a graph going below the x-axis? It's a no. So it is not possible by looking at the graph, my range or the y value is a negative value. There's no negative value my graph is taking. So I say range is y belong to real, but y is greater than or equal to 0 because we can see all the possible values my graph is taking are all positive values, isn't it? You see that?
Yeah.
All right. Now going back to some other functions. So quadratic function is something that we talk about in detail in grade 10 class. So I think that when I come back to my next lesson that I finish teaching factoring, that you should be able to understand a lot about the quadratic stuff. But let's going back to the function called square root function. So if you have a calculator, can you find me what is square root of -16 is?
I don't have a calculator.
You don't have a calculator, okay. How are you joining? How are you joining the class? Like, how
Oh,
did you
I
join
can do
it?
it on laptop, yeah.
Yes. So can you try to find out what the square root of -16 is? Okay, what did you get? Square root of negative 16. What did you get?
It says 4i.
Ah, so you didn't really learn what is I is. So calculator, the online calculator was smart to get that answer. But technically speaking, if you do a real calculator, square root of negative 16, it is going to say math error. It's going to say math error because you cannot find a square root for a negative value. So there's a reason is. So let's think about negative 4 squared. If I square negative 4 times negative 4, 16, isn't it? So there is no way when you square a number, you will get a negative number. Are you following that?
Yeah.
Okay. So we want to see how to graph this particular function. But what we can see is there is no way my x can be negative, right? Because there's no negative value. So what we're going to do, x belongs to real, but all the x value must be positive. There's no way I can divide a negative value. So what we're going to do next, we're going to create a table of values to see if we can graph it. So let's going back here, x and y. Let's start from -9. I mean, positive 9. Well, let's start from 0. So square root of 0 is going to be 0. Square root of 1 is going to be 1. Square root of 4 is going to 2. Square root of 9 is going to 3. So let me sketch this. This is this point. And 1 comma 1 next point. And then square root of 4 is going to make 2. And square root of 9 is going to make it 3, isn't it? Now, if I want to connect it, this is my shape of the curve. Did you see that?
Yeah.
All right. So that's being said, we can clearly say all the y values. There's no way the y is going to be negative. We can see we start from here. We're going to see all the y values must be greater than or equal to 0. Are you following that part?
Yeah.
Okay. Now we're going to go back to the next one. So the square root function and then the reciprocal function, the absolute value function has never been introduced in grade 10. The only function that you learn in grade 10 is the linear and quadratic. But as you're going to grade 10, the quadratic relation is something we're going to see it soon. Next class, we're going to spend time on talking about quadratic relations, so you won't get lost when I continue my functions. Now, going back to the next function, reciprocal. Obviously, you know why it is called reciprocal, because it's 1 over. Now, when you have 1 over, do you think I can divide the number by 0? Can I divide it by 0?
Isn't it just 0 then?
No, can you use
Oh, it's undefined.
Undefined. So that means I can't have any values for x except 0. So the domain is going to be defined as x belong to real, but y must be, x must be not equal to 0. There's no way you can take x is not equal to 0. Now what we're going to do, we're going to sketch this. So how do we sketch it? We're going to do the table of values. So you're going to see in my table of values, x and y. So let's start from -2. So 1 over -2, -0.5, -1, 1 over -1, -1. 0 is not defined. 1 is going to be 1. 2 is going to be 0.5. Make sense? So we're going to sketch this graph. So let's go back to sketch it. -2.5. So somewhere here. And then 1, 1. So 1, 1, it's just going to be 1, 1 here. And then if you see -1, also -1, I mark. And then 1, 1. Oops, I'm not marking that correctly. My bad. So 1, 1 is this point. 2, 0.5. 2 is 0.5. Now, if I'm going back to -2, I -0.5. So -2, -0.5 is here. -1 is here. So if I'm going to be taking more points, the way the graph is going to look like, it's going to be something like this. The graph is going to be just go close enough to there, never going to touch it, the x-axis. It will just going to be go through here. And we know why it is not going to touch the x-axis, because it's not possible to get that x is 0, isn't it? Are you seeing that picture? The graph?
Yeah.
All right. So now, and you can clearly see why when x getting larger and larger and larger, it's going to close enough to 0. Because if you divide a number by 1000, you got 0.001. Similarly, if you divide this number by 10,000 like that, 0.000001, isn't it? So now, if you really look at the picture, the y's take all the possible values. Y is going to take all the possible values. But y cannot take a 0 because we can see the graph never going to be cross the x-axis. Did you see that?
Yeah.
All right. So that is called the parent function for reciprocal. Last not least, absolute value function. What is absolute value function? Is the absolute value mean don't care about that sign. Absolute value of -5 is +5. Absolute value of -2 is +2. So if I'm going to sketch the graph for the absolute value function, this is very similar to the line. -3 is going to be 3, -2 is going to be 2, -1 is going to be 1, 0 is going to be 0, 1 is going to be 1, and so on, so on, so. So what that means, it's going to be look like something like this. So let me mark the point. Tick, 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 tick. On the negative side, it's also going to go this way because we can only get positive value. Do you see that picture?
Yeah.
Okay. So this is the absolute value function. So how do we state the domain in range? The domain, where I am. So domain, x belongs to real, but the range has a restriction. Y belongs to real, but y must be greater than or equal to 0. Are you seeing that picture based on the graph?
Yeah.
All right. Now, for each value, justify your parent function. So this is some practice question they're giving it. The next one illustrates the intersection of each pair of functions. We're going to be going back to a few things here. All right. Now, so this is a 1.3 section where we're going to be explore the function. So let's going back to C. We talk about the following function. F of x is equal to x. F of x is equal to x squared. F of x is equal to square root of x. F of x is equal to 1 over x. F of x is equal to absolute value of x. So each table of values identify the parent function by its equation. So let's call these guys A, B, C, D, and E. So A, which function match with A? Which function do you think match with A?
A.
A. So in A, if x is -3, y is supposed to be simply the value of x -3, but that's not the case, isn't it?
Yeah.
So A doesn't match. So which one, A or B or C or D or E? The answer is on the table. It's on my screen. It's obviously in my screen. We just did this, lady. It's an absolute value function, isn't it? For all the negative and positive, you get a positive answer. Absolute value function, isn't it?
Yeah.
Okay, which one do you think match B?
C.
C, that's right, yes. Okay, which one do you think match C?
B.
That's right. Which one do you think match D?
D.
Okay. Now, given the parent function has domain, minimum value, symmetric about the y-axis, has domain as the range, has a vertical asymptote. So I'm going to going back to the keyword they're talking about asymptote. So asymptote is basically a line that graph of a function gets closer and closer but never meets. So if you look at this graph, my 1 over x graph going to two different directions. One is just going close enough to the x-axis, The other one is going close enough to the y-axis. Did you see that? The one that's going close enough to the y-axis called the vertical asymptote. So vertical asymptote. Vertical asymptote. It's going to the y-axis. Y-axis has a name. The equation of the y-axis is x equal to 0. Because if you plot any points on the y-axis, x coordinate is 0, isn't it? It has a horizontal asymptote. Horizontal asymptote because it doesn't hit the x-axis. Y is equal to 0. Because on the x-axis, all the y coordinate is 0. Are you following that picture?
Yeah.
Okay. So this question number 2 is much more about what we have done. We talk about, so which one of these functions, the thinking question, has the domain belong to all real, has a minimum value, it's symmetric about the y-axis, the domain and range are equal, vertical asymptote, passes through a given point, the range is greater than or equal, and then we didn't talk about this one jet, its own inverse, we didn't talk about the jet, is variant under the rotation of 190 degree about the origin. We didn't really talk about that yet. So that's a new concept that we're going to talk about. So let's do some practice. Can you tell me?
May I go to the washroom?
Yep. you back? Let me know when you're back.
I'm back.
All right. So based on this example, let's see if you can answer the first question. Which one of the following functions has the domain R? So you should know the name for the function. So the way we call it, well, I'm going to label it. So this is linear function. So this is linear function, quadratic function. This is square root function, and reciprocal function, absolute value function. So we have talked about it. I show the shape of the curves. So which one of the following function has the domain that's simply real?
Um, the second one,
So how about the first one?
that one too, I think.
So that is 1 and 2, isn't it? Okay.
Yeah.
So the next one they're talking about as a minimum value. Minimum value mean all the values are above certain value. That means there is a minimum value, we can find it. So, and then to find a minimum value, a graph that minimum value should have a shape goes like this. This is like a valley, minimum value. So which one of the following curve you see that have a shape like this?
Um.
So this is very important to just visualize it. So going back, so you see that this one has a minimum value, isn't it?
Oh yeah, the quadratic one.
Quadratic one has a minimum value. Okay. So that is going to be y is equal to x squared. All right. Now, the symmetric about the x-axis. What they mean by symmetric about the x-axis? This is more about quadratic relations. When we talk about quadratic relations, we will talk about it. If you look at the quadratic graph I draw, it's if you just observe that it's basically go like this, and this is called symmetric because if you fold this edge, it will collapse with the other edge. Do you see that?
Yeah.
All right. So there's a couple of things that we need to move on, but which I'm not going to be start today. So I have one of the student that he had a track and meet, he didn't come today. So to understand the translations of parent function, we really need to talk about quadratic relations. So without that, this topic of translation will confuse. We go from there and then we talk about command. So we're going to talk about a quadratic relation of a grade 10 math. So hopefully that you won't miss in the grade 10 math class, which is scheduled to be at 11. Oh yes, last class we talked about it. So next week on Thursday, that class is scheduled to in Sri Lankan time. It's 8 p.m. Do you think you can come to 8 p.m. class rather than come to 12:30 p.m.?
Yeah, I think that works.
Yes, so we're going to start that class at 8 p.m. So for me, it's 11 to 1. So I'm going to introduce you about quadratic relations. That's where we're going to be finished factoring. So we're going to dive in. Now, before I leave you, the homework question I really want you to do is in grade 11 class. So if you can't see the grade 11 class, you have an access to the textbooks. So I think I put the textbook, yes. And then are you in my grade 11 class? Let's see if you're in a grade 11 class. Kavin, Kishore, Lakshya is there. Yes. So if you're going back to the grade 11 class, you see the textbook here. And then you can access the textbook. So we finished learning the session in chapter 2, all about factoring and simplifying. So the only way that I'm confident that you got that unit is by doing a lot of practice. So what I'm going to do at this point for that unit, I think we started to do some questions, so I take it up. So there's a chapter review and a chapter test. I'll show you which page is that. So you're going to do the chapter review. You can see those questions are coming on page 107. No, that's not chapter review. That is simplifying rational expression, that chapter review at the end. Okay, we have done it. Adding, subtracting polynomial expression, we have done it. So what I want you to do, you're gonna do page, where to start? Page 130 on the textbook, 132 and 133. And then there's a chapter test, which is 134. So if you can do those questions as your homework, which is chapter 2, we will going back to the transformation that's being mentioned there after learning about the quadratic relations on Thursday class. So your internet is working. How are you joining my class? Are you joining through Wi-Fi or what's happening?
Right now I'm joining through Wi-Fi. It's working.
Okay,
But
Wi-Fi.
sometimes it like, pardon?
Are you using your laptop, right? Your laptop is connected to Wi-Fi.
Yeah.
Okay, and then you're in Jaffna.
Pardon?
Are you in Jaffna or you moved to Colombo?
I'm in Jeff now.
Okay. So that seems to be your Wi-Fi is working, Pat, because there are a few people, they try to join in their Wi-Fi, but your Wi-Fi is good enough to just do my lesson and also to see things on the Jamboard. So I will let you go. I'm going to meet you again on Thursday, 8 p.m. 8 p.m. Sri Lankan time.
Okay,
All right. Bye-bye then. You can go to sleep now.
bye.